Hello and welcome to another video. In this video we're going to be working on special positions in a binary matrix. And in the problem you're given an m by n binary matrix and you want to return the number of special positions in the matrix. A special position means that if it's a 1, no other element in the row or column is a 1. So for this first example, this is a 1, but there's another 1 here, so it's not a special one. And this blue one is because everything in the row and column other than themselves is not a 1. Let's get rid of that. So like here, this is not a special one either. So it's just 1. Then in the second one, all of these are special because they're the unique 1 element in its row and column. So here it's the only 1, and here it's the only 1. So let's actually draw a matrix and figure out how we would do this kind of efficiently. So let's get like this. Should be good. There we go. And what I'm going to do is I'm just going to draw 1s. I'm not going to draw 0s because like there's no point. So everything without a 1 will just be a 0. So we're just going to say like there's a 1 here, 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 and here, let's say. And everything else is 0. So if you were to do this brute force, you would find a 1, and then you would look through the row and look through the column to make sure there's no other 1s. You'd find a 1, look through the row and look through the column, and so on. And this would give you m by n for going through the matrix, and then for each one you find, it would be n plus n. So not great, but obviously in an easy problem anything will pass. So we need to try to figure out a way to do better than that. And we can actually get rid of this m plus n, right? Like to look through the row and the column. Instead of looking through the row and the column, we can just pre-compute totals for the row and the column. And this is very useful for very hard problems where you pre-compute something for the row and the column. You can pre-compute a total or keep track of like a maximum or some other kind of thing, right? Maximum, minimum. So then you don't have to do this traversal, so it'll save you a lot. So what we're going to do is we're going to have two arrays. We're going to have one for the rows. So for the rows, we have 5 rows here. We're just going to initialize it to 0. And for the columns as well. So 0. And we can even make these bigger and index them to make it more clear what's going on here. So let's say this is index 0, index 1, index 2, index 3, index 4, index 0, 1, 2, 3, 4. And now basically what we're going to be doing is we're just going to pre-compute a total. So like for every number, we're going to add it to its appropriate row and column. So here, we're going to increase the row in the column, which will be row 0, column 0, and so on. So now let's just look what these totals will be. So row 0 will have a total of 1, row 1 will have a total of 1, row 2 will have a total of 2, row 3 will have a total of 1, and row 4 will have this. Then column 0 has a total of 2, column 1 has a total of 1, column 2 has a total of 1, 1. So now that we have these pre-computed, we can, once we find a 1, in O of 1 time, figure out if this is the only one. So we're going to have a result variable. We'll just make it 0 to start off. Essentially, like, let's look through this one. We're going to check the row and the column. And in order for it to be the only one, the total for the row and the column that this is in has to be 1, right? Because if there's more, then it'll be more than 1. So for 0, 0, we'll check these 2 elements. These are not both 1. There's a 2. So that means this column has 2 elements, so this does not work. Now let's come over here. So this is row 1, column 2. So row 1, column 2. This does work. So this is one of our answers. Now let's go over here, row 2, column 0. So row 2, column 0 does not work. This one's obviously not going to work as well, right? Because this row is going to have 2. So this does not work. This does not work. This one, the row and the column will both be 1. So just to double check, row 3, column 1. 1, there we go. So another 1, and this one will also work. So row 4, column 3, 1, 1, there we go. So we have 3. And that's how you can get it down from, remember what we had it before, we had m by n, m plus n to check. Now we have an O of 1 to check for the row and the column, right? We can just index it into the row and the column and pre-compute. So you can probably do this faster, but essentially I'm just going to do a 2-pass. So the first pass will get these sums, and the second pass will check if the ones are valid. You can probably like do something with these, but it's going to be the same time complexity, so it doesn't really matter. So essentially we're just going to do a 2-pass, and yeah, pre-compute this first, and then check all the ones and make sure if they're valid or not. So let's let's code that up. This. Okay, so first thing, we're going to have the rows and the columns for like almost every problem you want to do this. So then also you're going to want to traverse your actual matrix, and you're going to want to make this rows and columns array. So we'll say like R check equals 0 times rows, and column check, it's going to be 0 times columns. We want to traverse through our actual matrix, so like for row range rows, for call and range calls. We're just going to say row check plus equals matrix of row column. And remember, we want to increment the correct row, so we're going to increment row. And same thing for the column, so column check, column, increment by whatever is there. If it's 0, it won't be incremented, otherwise it'll be incremented. Now we just do another pass and have a result variable as well. And we can just say here, if the matrix at row and column is a 1, or you can, just like this, and row check for this row is a 1, and column check for this column is a 1. That means this is the unique element for the row and column, so we can increment the result. Finally, return it. And we can hit run. And there we go. And okay, so we have a pretty efficient one. So here at the time, now essentially we're just doing a 2-pass where it's OM by N, and this is O of 1. And for the space, we stored a array for the row and the column, so that's just going to be M plus N. So we got it down from M by N times M plus N to M by N. Okay, and so that's going to do it for this one. And this is a very useful trick for harder problems. So, to store these exact, like some kind of variable for the row and some kind of variable for the column in an array, whatever you need, and then you can get these in O of 1 time for whatever element you want. So it is going to help you get time constraints down. I think I did it actually, one of the 2 or 3 hardest problems I've ever done on LeetCode, I used something like this. So that was like a 5th of the problem though, but yeah. Anyway, that's going to be all for this one. So if you liked it, please like it, and please subscribe to the channel, and I'll see you in the next one. Thanks for watching.